So I want to write the area of this rectangle in terms of x, and I know that the area is the base times the height. And I know that the base is x, and I just need to find out what this height is. Now they tell me it's an equilateral triangle, so then I know that all the angles are 60, and so since the height is at a right angle, this is a 30, 60, 90 triangle. Oh, so that's going to help me find the height as long as I know what this side is. Now this little length here, it's not the full 10, nor is it 10 minus x. If I did 10 minus x, that would give me what's left here. Like if x were 6, then I'd have 4 left in here, 2 and 2, right? Or if x were 4, then I'd have 6 left for here, 3 and 3. So what this little length is going to be, it's 10 minus x divided by 2. So my area, and that's, oh, so this little part here is 10 minus x divided by 2, and that's the shorter leg of this 30, 60, 90 triangle. So the longer leg is 10 minus x over 2 root 3. So that's the height. So my area is the base, which is x, times the height, 10 minus x over 2 root 3. Excellent. So we have a formula for area all in terms of x. And I could make it a little bit cleaner. What if I went ahead and distributed the x, so I'd have 10x minus x squared over 2 root 3, and I could either distribute in the root 3 or take it out. I think I want to take it out. So I have 10x minus x squared times root 3 over 2. And that looks a little bit cleaner. So there's a formula for area all in terms of x. And they also ask us to maximize the area of this. So we could have had a rectangle where x was really big, and then it wouldn't have as much area. Or somewhere in the middle here, when x is like about where I have it, it looks like a maximum. Because if I made the x small, you would have a skinny rectangle with not as much area. So whenever they ask you to maximize or minimize, unless you know calculus, you're hoping that it's a quadratic because its graph is a parabola, an upside down parabola because this is negative, and the max is at its vertex. So we have a formula to find the vertex, x equals negative b over 2a. So here x is negative b, which is negative 10 over 2a, which is negative 1. I could have put the root 3's over 2 distributed in there, but they would just end up canceling out, so it works. So we get a maximum area when x is 5, and so that'll be the x that'll maximize your area. If you wanted to find out what the height would have been, the height would have been 10 minus 5 over 2 root 3, so that's 5 over 2 root 3. And then the area, you could have either done base 5 times height, 5 over 2 root 3, which is 25 root 3 over 2, or you could have put the x back into our area formula, any one of those area formulas, and gotten this. So that answers our question. So we have an area formula of that, a max area when x is 5, and the area will be 25 root 3 over 2. Excellent.